sorry if you see any droplets on the projector here. Yeah, it's because it's really hot today, and that's just me sweating. So don't mind that if you see it. All right, problem number 16, page 418 says a 4-digit integer wxyz, in which w, x, y, and z each represent a different digit, is formed according to the following rules. So we're given the rules there on the left, and the problem asks, what is the 4-digit integer? So let's ask our who, what, when, where, and how questions, starting with the what question. What kind of problem is this? Now, at first looking at this, it might seem like this is an algebra problem just because we see all these variables or all these unknowns. They're not actually variables, they're unknowns. And that's what makes this not an algebra problem. But if at first glance it looks like an algebra problem, we might be tempted to say it is, and that's actually okay, because we can't take too long analyzing this thing. So I'm actually going to put a question mark here. But we might say that it's an algebra problem. The when question has to do with how much time we have left on this section, and this is number 16 out of 18. So we're probably running short on time. The where question, since this is 16 out of 18, we can assume that this is going to be a pretty hard question. And then we get to the how, which is what kind of method are we going to use to solve this? And this is the trickiest question out of the 5 for this particular problem, because it's really sort of unclear looking at this as to how we're going to solve it, because we don't have answer choices to work with. We don't even know if this is an algebra problem or not. It's a very puzzling problem, which is what actually makes it kind of fun. But based on sort of a lot of the question marks we have and a lot of the questions that are still unanswered after we ask these 5 questions, or 4 at this point, the answer to the who question in this case just might be not you. This is a good example of a problem you just might want to skip on the test, or skip it initially and come back to it if you have a little bit of time, because it's just sort of a tricky problem and not necessarily something we're used to seeing. But we're going to go ahead and go through this problem. And so let's first talk about our givens, and I've already circled a few things here that we want to take note of. First, we're looking for a 4-digit integer. So that's actually what we're solving for. Remember, they're asking what is the 4-digit integer. And then they tell us something important, which is that each digit is represented by a different number. Therefore, our 4-digit number couldn't be something like 4444. It couldn't even be 4041. Every digit has to be different. Now notice if we're talking about digits, we're talking about positive values. So W through Z cannot take on a negative value. Okay, so let's talk about some restrictions we have on these digits. Notice that X, Y, and Z can be any digit 0 through 9, right? As long as they're all different. X could be 9, Y could be 3, Z could be 1, possibly. We haven't started talking about these 3 restrictions here. But X, Y, and Z could theoretically be anything from 0 to 9. Now, W, let me ask a question. Can W be 0 through 9? And it's tempting to say yes, but W has this extra restriction in that it can't be 0. W cannot be 0. So W can be anything 1 through 9. And the reason W can't be 0 is because if it was, we actually wouldn't have a 4-digit integer, we'd have a 3-digit integer. Because if, for example, we had the number 0, 1, 2, 3, that would be 123, which is actually 3 digits and not 4. So those are our restrictions. Now let's start looking at these 3 equations they give us here. And I want to ask you, of these 3 restrictions, which one is the most restricting? And what I mean by that is, I know it sounds like a riddle, but what I mean by that is which of these 3 equations actually gives us the best place to start. And I'm going to point you to look at equation number 3. And the reason this equation is a good one to start with is because we know, based on this one equation, that W has to be greater than or equal to 5. Now, how do I know that? Well, I know that because if W was less than 5, that would make Z a negative number, which we know can't happen. We know that can't happen. Z has to be positive. Therefore, W has to be greater than or equal to 5. So that's a really good place to start because it means W is between 5 and 9. All right, so that gets us somewhere. So now from here, I think the best thing to do is just a little bit of guess and check / trial and error. And that's what makes this problem so weird, is that the best strategy here, at least in my mind, maybe you can think of something else, is trial and error, guess and check. So let's just start with the lowest possible value that W could be. So let's just say, let's let W equal 5. Now if W is 5, then Z, according to equation 3, has to be equal to W minus 5. And if W is 5, then Z is 5 minus 5, and Z is 0. Okay, now let's look at equation 2 here. If W is 5, then 5 equals Y plus 1, and we see that Y, if we subtract 1 from both sides, Y is equal to 4. So we see that if W is 5, then Z has to be 0, and Y has to be 4, and then according to equation 1, X would be equal to W, which is 5, plus Y, which is 4, plus Z, which is 0, and X is going to be 9. And we see that when we do this, when we use these numbers, amazingly, everything works. We see that this is possible, that this gives us a 4-digit integer, right? Now, just because one thing works doesn't necessarily mean we got the right answer. We'll want to check our logic by plugging in another value and making sure it doesn't work. Because it's possible when the first thing we try works, we always have to be a little bit critical of our answer and maybe double check it just to make sure we didn't go wrong somewhere. So now what I'm going to do is I'm going to say, all right, I want to check my work. So now let's let W be 6. So if W is 6, then according to equation 3, Z has to be equal to 6 minus 5, and we see that Z is going to be 1. According to equation 2, if W is 6, then 6 equals Y plus 1, and we see that Y has to be 5. And then according to equation 3, we're going to solve for X by plugging in 6 for W, 5 for Y, and 1 for Z. And we see that that yields 11, which isn't possible. We need a digit for X, and 11 is a 2-digit number. We need a 1-digit number for X. Therefore, we see that when W is 6, this doesn't work. And based on some logic and some intuition, we can see that actually as W gets greater, as we start trying bigger numbers for W, this value for X is going to get even larger and larger. So we're going to see that nothing greater than 5 for W is going to work. Therefore, this first situation, what we tried initially where we let W equals 5, is the answer to this problem. So, again, we go back to what are they asking us for? They're asking for the 4-digit number. So now we just plug in our values for W, X, Y, and Z to get that 4-digit number. So W is 5. X was, remember we're using this situation here. X was 9. Y was 4. And Z was 0. So our answer to problem number 16 is 5,940. Feel free to email me if you have any questions on this one. It's a little bit tricky and a little bit weird. So I know we kind of rushed through that a bit, but this is a time-consuming problem and one that yeah, you just might want to skip on the test if you get something like this, because it's just tricky and it's just odd enough to where we don't want to waste too much time trying things that might not lead us anywhere.